Hello everybody, my name is Jorge Lopez Parages. I am a postdoctoral researcher in the University of Malaga, and today I share with you this result about El Niño influence on Ron Sardinella distribution along the Northwest African coast. The results were published last year in Progressing Oceanography, and this study was done in collaboration with different colleagues from different institutions within the European Prephase and Triatlas project. Let me very briefly introduce you the Canary upwelling system, which is one of the 4 instant boundary upwelling systems in the world, characterized by upwelling favorable winds. And although they represent a very limited percentage of the total surface ocean, they present a strong importance for biomass, for life. For example, they account for more than the 20% of the global fish catches. In particular, the Canary upwelling system present important stocks of small pelagic fishes, which are really important for the economies of the surrounding countries. This upwelling in the Canary upwelling system is mainly characterized by its strong seasonal variability. Because although there is an area with a permanent upwelling all the year round, to the north and to the south, the upwelling is really seasonal. But superimposed over this seasonal variability, there are changes also among the year, which suggests an important interannual variability as well. And this study is about this interannual variability and its link with the Sardinella variability. To face this study, ideally or theoretically, we could use observation. However, there are cases in which the quality of the observation is low, or directly the number of observation is really scarce. This is the case of Northwest Africa. And in this case, it's becoming more and more popular in the community the use of the so-called end-to-end modeling approach, climate to fish in our case. These models present uncertainties, of course, but they are useful for addressing mechanisms and designing sensitivity experiments. Without going into deeper detail, our modeling setup is component by the Ron-Pistes couple model, physics coupled to the biochemistry. This model is forced by the atmospheric condition with our analysis, and we obtain from it information related to temperature, salinity, plankton, chlorophyll, etc. This information is in turn used for running an individual base model of Sardinella, just for Sardinella, and for this specific domain. This model is designed by Brochard et al. In 2018. They validate it with the available observation. They show how it provides realistic responses of Ron Sardinella to the environment. From the beginning, we forgot about the onshore-offshore variability, because we observe how the variability in the meridional direction to the north and to the south of Sardinella was much more marked. So we simplify our study by using the latitude as a measure of the spatial location. This allows us to do this type of Hufmuller diagrams in which we plot the latitude versus the time expected in months. And we see clearly the displays of Sardinella, the displacement along the year. The migration, which are consistent with the documented migration of Sardinella in previous studies. If we focus your attention in the northern part, between the Cape Blanc region and the Saharian bank, we see how a limited percentage of Sardinella is able to reach the Saharian latitudes, where the habitat conditions are really good for Sardinella in winter and spring season. However, only with the strongest swimming capacity are able to cross the Cape Blanc frontal area. If we focus now our attention in the variability, we see how an important variability of Sardinella abundance is identified in this area in winter and spring, in coincidence, interestingly, with a peak of variability in the intensity of the upwelling. In reality, with the meridional wind stretch, which is proportional with the upwelling. So we wonder at this point if these peaks of variability in both the Sardinella abundance and the upwelling intensity, the environment, could be related to each other. So to this aim, to deeper investigate this issue, we calculate an EOF analysis of the anomalous Sardinella abundance, and we obtain this pattern, this leading mode, as this pattern as the leading mode, capturing around the 50% of the total variance. These two anomalous center of action point that the anomalous meridional migration is a key pattern of abundance variability. But the most striking result came when we project the principal component associated with this Sardinella mode onto the global SST, because a significant and unclear El Niño pattern emerged. So the question is how El Niño could produce this anomalous behavior of Sardinella abundance of Northwest Africa. To answer this question, we would need much more time than we have in this presentation, but let me just highlight the type of reasoning we did in our study. For example, in late winter, what happened? Under normal conditions, in late winter, Sardinella began a migration to the south, mainly because the condition in the northern part became too cold for them. So they began a migration looking for warmer conditions, and to this aim they used the alongshore current to the south for serving energy. They displaced passively into this current to the south. However, during El Niño years, the condition, the environment change of Northwest Africa. Here we can see the regression pattern of the principal component of our Sardinella mode onto the global SST, sea level pressure, surface wind, etc. And we see consistent patterns with the documented response to ENSO in February and March, in late winter. But what happened of Northwest Africa? Basically, the condition become warmer than usual. So the habitat improved because the Sardinella, we can say that Sardinella sees less necessary this displacement to the south. But at the same time, the alongshore current to the south become weaker than usual. These positive anomalies show this weakening of the alongshore current to the south. So at the same time, not only the Sardinella see less necessary this displacement to the south due to the warmer condition in the northern part, but also they see more difficult this displacement to the south due to the weaker efficiency of the alongshore current for them. So the consequence is that the persistence of the anomalous accumulation of Sardinella off Cape Blanc during El Niño years occurred until well into the spring season, and this explains this positive accumulation, anomalous accumulation of Cape Blanc associated with El Niño years. But let me just conclude with this plot in which we correlate the Sardinella response in winter and spring with different variables. Please focus your attention just on the blue line in which we correlate with different lags with the tropical Pacific SSTs. So, for example, in summer we obtain correlation with the tropical Pacific SSTs in summer, with respect to the Sardinella response in winter, in the next winter and spring, we see correlation very high and significant. So, in principle, we could use this temperature in the tropical Pacific when El Niño is developing, to predict the Sardinella response of Northwest Africa few months after. Of course, we are aware about the limitation of our modeling setup, but we think this could be an interesting starting point for designing a predictive tool of Sardinella abundance from the ENSO-related SSTs. And here just three general conclusions. The anomalous migration of Sardinella is identified as a response to El Niño in a climate-to-fish modeling design. This link between El Niño and Sardinella of Northwest Africa occurred through a variety of larger scale and regional scale mechanisms. They are consistent with the available literature. This result could open the door for the development of a seasonal prediction tool of Sardinella abundance along the Northwest African coast from the ENSO-related SSTs. However, it's important to consider that this study should be considered as a starting point, and further analysis are still necessary. Here in this link you can find a more detailed talk of the result for those who are more interested. And that's all. Thanks a lot.